Hello, everyone, and welcome to another edition of Let's Talk ETC. I have a great guest with me today, Vaibhav Saini from Towards Blockchain, and he's going to talk about the InterPlanetary File System, or IPFS. IPFS, at least to me, seems like one of those technologies that I have an intuitive sense it's going to be extremely important in the future, but I always wish I had opportunity to learn more about it. And so I think Vaibhav is our guy to explain this important technology to us. So welcome, Vaibhav.
Yeah, thanks.
So I saw a little bit of your bio. You co-founded Towards Blockchain, the startup, and then you also developed some applications, IPFS Cloud and Cluster Labs. But the thing that stuck out at me is you were a dropout of the Indian Institute of Technology, IIT, and there was two reasons that stuck out. First of all, my impression is that that's the genius school. And then the second thing that's the idea was, so Bill Gates and Steve Jobs both dropped out of college. So I don't know, you dropping out of college, does that mean you're the next Bill Gates?
I don't know.
Okay.
Maybe.
Well, you also dropped out of a very prestigious school like Bill Gates did. He dropped out of Harvard. So it just reminded me of that. But anyways, that's enough about me. Enough of me talking. Why don't you introduce yourself and how you got interested in blockchain technology and how you found yourself doing what you're doing now?
I was introduced to blockchain in mid 2017. So, like many people, I started into the blockchain space as a trader. Like I traded Ethereum, Bitcoin, and other stuff. As a programmer, I thought like it will be interesting to dive upon like this blockchain world. So I was also interested in startups, and I have been working with a few startups at my college. But like those startups weren't that enthusiastic for me. So I actually left those startups and started my own startup with three more people from Google, Tesla, and MIT. So like since the start of the startup, I was the like technical lead there. Uh, uh, like in the initial days, I worked on Ethereum and Quorum and like few other DLT platforms. I wrote like bunch of articles on consensus algorithms and smart contract platforms, like Explore 30 and 40, like a lot of them. And I wrote a few articles on them, which are actually taught in Princeton University. And like in 2018, like maybe in August, I started diving more into IPFS world. So one of the things that I saw in IPFS was like there were not actually as many applications that there were in Ethereum. So like in Ethereum, you had like Mist wallet and tons of other applications that are provided solely from the Ethereum Foundation, like let alone from the community. But like in IPFS, uh, like it was mature enough, but like there aren't that many applications.
Right.
So I thought that there must be some applications that a normal user can use, because like IPFS seems to people like it's a pretty like hard technology to understand, but like IPFS is the top layer of what you see. At the core, it uses libp2p uh, multi multi hash and like lots of other like important stuff. So as a user, you uh, you should be able to use these technologies and like able to do what you are allowed to do in the real world. So I launched a open source project umbrella called Cluster Labs. Like one of the first projects in that was IPFS Cloud. So basically, what IPFS Cloud is it's a Google Drive sort of interface which you can use to store and share your files as you are using Google Drive. But like the total infrastructure is built on IPFS.
Okay, so does it copy your Google Drive files to to IPFS? Is that what it does?
Not exactly, but like the main goal here is to like make the interface so usable that like the user doesn't even understand that it is it using a centralized system or a blockchain based system, uh,
Okay.
like decentralized system.
No, right. I think that's a good approach. I hear a lot of that in the blockchain community with Ethereum and Ethereum Classic. People say that we're at the stage in evolution now that we really need to keep improving our user interface
Yeah,
so that people don't even, in some cases, don't even know they're using a blockchain. That's where we're at now.
yeah,
So yeah, that's
that's
good.
an end goal.
And so you worked on that, and so Cluster Labs is what's the relation again between Cluster Labs and
Basically, Cluster Labs is a umbrella of projects. Like IPFS Cloud is like the one of the projects that I was working on, and right now I'm working on its like the new iteration. Like it has the Cluster Labs has like much more to it. So like we have Google Docs on IPFS, we have search engine on IPFS, and like 3D. Uh, like you can actually share 3D collaboration models on IPFS. So like basically, if I share a 3D model with you, like a 3D model of a hand, I will in this centralized system I have to use a server, but like in the system that we have built in cluster labs, you don't actually need a server. So like it totally works on peer-to-peer system. So it actually tests the limits of IPFS
interesting.
because you are mirroring the 3D objects on IPFS.
Okay. Okay. So I think it's fascinating. Everybody gets intrigued by different technologies. So I got obsessed first with Ethereum and then now Ethereum Classic. And so you were extra fascinated with IPFS, and so you
Yeah.
wanted to promote it. So that's kind of interesting to me. So the audience is they may or may not know about how IPFS works. So why don't you give the audience, the listeners, a short description of
Yeah.
what IPFS is in the basics and how it works?
So like I would like to take like 15 minutes to
Sure.
actually give an idea what's IPFS. So first, let's expand the term IPFS. It's interplanetary file system. So the basic goal of IPFS is to say that it's so robust data system that can even span across multiple planets. So if you're actually planning to get data connection on Mars, IPFS is the thing to look out for. So basically, in order to understand how IPFS works, it only makes sense when you actually understand what are the problems. So let's understand how current internet works. So simply put, internet is a collection of protocols. So how do I define protocols? So basically, if I have to talk to you, we both have to use same language. So like if I'm talking in English and you are talking in Chinese, so like it doesn't make any sense. So
Mhm.
like in the same sense, if two computers have to talk, they have to use same protocol, same language. So the basic protocol that computers use nowadays is HTTP. That's the same sign that you see in your URLs that you go. Like HTTP is s//google.com.
Right.
That's the same protocol that you use. So there's a bunch of problems in it. So basically, HTTPS is a request response protocol. So when you go to google.com, the web page is uh, hosted at like some Google server. So when you go to google.com, you actually telling the Google servers, hey, that I want the homepage of google.com. Please give me the web page. So the server gives you the response back with the web page. So this protocol actually worked good at the time when it was made in like 1960s, but like as you scale up the systems, it actually messes up. So let's explore some basic problems. Let's say you are sitting in a lecture hall and the professor asks you to go to a specific website. Every student in the lecture makes a request to the website and are given a response. This means that the exact same data was sent individually to each student in the row. If there are 100 students, then that's 100 requests and 100 responses. This is obviously not the most efficient way to do the things. Ideally, the students will be able to leverage their physical proximity to more efficiently retrieve the information they need. So if my page is buffering, I should be able to get my friend like that. Can you give the web page to me directly, rather than I asking the Google servers to get the data.
Right.
So HTTP also presents a big problem if there is some problem with the network. So if my ISP is going bad, so like I can't actually access the internet. If my internet is blocked by my country, so I can't actually uh, access the internet. And also there are a lot of broken links that exist in the HTTP. So like if Google servers, if Google decides to take down the website, so like there's a broken link in the web. So basically, that's a not censorship. There's a censorship element to that.
Right.
Also, the location based addressing model of HTTP that uh, is encourages centralization. It's convenient to trust a handful of application with all of our data, but because of this much of data on the web is soiled, this leaves our providers with enormous responsibility and power over of information. HTTP is great for loading websites, but it wasn't actually designed to transfer all of the data that we are using today, like streaming movies and watching like matches, etc. These constraints possibly enable the emergence of the mainstream success of alternative file sharing systems like Napster and BitTorrent in the late 90s. Fast forward to 2019, where on-demand SD video streaming and big data becoming ubiquitous. We are continuing to upward march of producing and consuming more and more data, along with developing more and more powerful computers to process them. The major advancements in the cloud computing have helped to sustain this transition, but however, the fundamental infrastructure for distributing all this data has remained largely the same. So basically, we actually need to do some ground up changes in order to like move forward in this digital era. So this is where IPFS comes in.
Right, right. Yeah. So I agree with all of your points. I saw a brilliant video. I believe the network engineer's name was Van Jacobson. He
Yeah.
an initiative called Name Data Networking. He was at Xerox Park. He's a researcher, and he was elaborating on the problems with the internet. And so it seems like IPFS is like the solution to his problems that he elaborated. He explained the same problems in a slightly different way, which I kind of liked. Maybe see if you like this. He said that the internet, when it was designed in the 60s and 70s, they were trying to essentially make a better telephone system where it's point to point.
Exactly.
Whereas the way that we use the internet today, we don't really care about point to point. We use it more like a radio. We want to broadcast content to lots of users, like from Facebook, from Netflix. And so imagine if every radio station, every TV station, everybody had to phone in to get their content. That would be very inefficient. So what I think a different way that you might say how IPFS is architected is to try to be a more broadcast friendly system. Is that correct?
Yeah, you can say that.
Okay,
that is how our search engine for IPFS works. So basically, as you know, that these all the nodes in the IPFS, all the systems that are in the IPFS networks broadcast these signals. So basically, we listen for these signals and we publish that data on a search engine.
Right. Yeah. And then I also like what you said, another, just to show you how the architecture affects and limits a system. So we currently on the web, we have to type in an address to a website to access content, but we don't really care about the website. We care about the content. So like if you're trying to get the New York Times headlines, you really don't care which server you get it from. You care about getting it. So we should really focus on the content, not the not the location. So, yeah. So that was a good point.
Yeah, basically that also reduces the duplication problem. So let's take Instagram for example. So like if you are sharing same photo that I'm sharing, so basically these are two different photos because the first photo is shared by me as a user and the second photo is shared by you as a user. So the addresses of these photos will be different. But like if you compare this to an IPFS based system, these two photos will be exactly the same because here in the IPFS we actually uh, care about the data. So these files are hashed basically. So basically, when I take a photo, so when I store it into the IPFS, what actually happens is that like I take the photo and hash it. So basically, what hashing means that like you take anything like your name or a Bible and put it into a hashing function, and it will output a specific string that will be specific to that Bible or your name. So if you put your name in 100 times in that hashing function, it will return the same string. So basically, when you upload a website on IPFS, it will give you a unique address that will be same if if I uploaded it to the IPFS or you uploaded it to IPFS. So it will go same for the images. So like if you coming to our example, if you uploaded a photo to IPFS based Instagram and I uploaded the same photo on IPFS based Instagram, the photo will be essentially picked up from this any source that matches that hash.
Right. Yes, that was another thing that I liked when I learned about these content-focused architectures. Yes, I think that is a brilliant and very useful idea to use hashes to identify the content. Yeah, so you immediately know if some two locations, two pieces of content are the same. Yeah. Yes. Yeah. And also, I think for the listeners that maybe are still trying to understand why do we need a different architecture? Maybe BitTorrent is what they're most familiar with. So BitTorrent shows you the potential and the promise of slightly changing the architecture of the web and how you could potentially make something much better, right?
Yeah, absolutely.
Okay. So so hashes, they're the workhorse of cryptography. They have so many use cases, and so identifying content on a file storage system is definitely one use for it. So we identify content by hashes, and who actually serves the content? Who hosts it then? Can you describe that?
Okay, basically, if we wanted to make Instagram on maybe IPFS, so how we will do it? So, like every mobile that is using Instagram will be hosting it. So basically, if I'm seeing your photo, so basically anyone, if my friend is also wants to see the same photo, it will not have to go to the Instagram servers and fetch that data. He can actually get the data from me or anyone else that is seeing your photo. So because like if I'm seeing your photo, my phone actually has your photo. So the people who are using the IPFS platform, the applications are actually serving the data. So if you're watching a movie in Netflix, you can actually also serve the same movie to another person. So basically here, the people, the users actually become the infrastructure. So that actually drastically reduces the cost of the developers and the company. Because like right now, you have to serve like thousands of data centers in order to like make the system work. But like in IPFS, like your users are your infrastructure.
Right. So everybody, to use old language, so everybody not only is just a client, they're also a server. And so that's of course is how Bitcoin, or excuse me, BitTorrent works.
Exactly.
Now we were criticizing the internet's architecture and how it focuses too much on the site, the location of the data. However, now with the new architecture, the obvious question is how do you find the data that you want if you don't know who is hosting that specific data? Do you see? So how do we solve that problem, the search problem?
Search problem. Okay. So basically, like I told earlier, that like if I just took a photo of a cat maybe and like upload it to the IPFS based system, so it will give me through the use of hashing, it will give me a specific identifier of the cat picture.
Right.
So basically, when uh, I can actually give this identifier, like basically this identifier is a long string that doesn't look that good. So if I give that string to anybody in the world, he can actually fetch that same cat photo, irrespective of knowing where this cat photo is served on. So basically, if I have to like comparing it to the centralized systems, if I have to go see the Google web page, I have to go to google.com. That's a
Right.
specific web address that I have to actually type into the browser. But like in case of IPFS, I don't actually go to the specific name or anything, specific location of the file. I just go into the browser and just uh, paste uh, that
Yes.
specific identifier, and like it will be fetched
Right. But
from
it's
anywhere that where it resides.
right. Is okay. So I understand what you're saying. Is this a fair criticism of IPFS from the way that you've described it? Is it fair to say that the search is a little bit more inefficient because all the peers have to gossip? Do you have this file? Do you have
Yeah,
this file? Right? You see what I'm saying? And you have to go on maybe.
yeah, that's similar to what happened to BitTorrent, because when like people who have used BitTorrent actually know how painful it is to actually use BitTorrent. But I actually don't think that it's right criticism, because like our current infrastructure is not actually built to perform this type of searches. It's like going to the era when horses actually were used as a main system of transportation.
Right.
When I when the automobiles were first introduced on these roads, people thought that it will never work. That's the same story with IPFS and platforms like BitTorrent, because the infrastructure that is built for the centralized use case can't be actually just pasted on for the decentralized ecosystem. So if we actually scale the system up, we can actually perform much more better than the centralized systems.
Okay, so it's not so even though it seems like it would be
Yeah,
a problem,
because
you're
like
saying it's not really that much
yeah,
of a
because
problem.
like right now there are not many IPFS nodes, so like it takes a bunch of time to go through like a bunch of nodes. But like if there are a lot of nodes, uh, you can actually get a file. So
Okay.
like for example, there are like a really less number of nodes in India with, if we talk about IPFS. So if I search some content on IPFS, it's high probability is that that comes from a node from like US or Europe. But like if there's a big adoption on IPFS, so like I can find the same content in my country. So that will be really much faster.
Okay. Okay. Now, here's I don't know, is this a good business idea? If for somebody that wants to get content as fast as possible, in the future, could there hypothetically be like another company like Google that indexes the entire IPFS network and has all the hashes and all the nodes, the peers that have that specific hash, so you could go directly to that node?
Yeah, I think so, but like there's a long way to there because like IPFS suffers from same problem that BitTorrent and actually particularly Napster uh, Napster suffered from. So basically, Napster, like as we all know, it got down because of the privacy, uh, the record label issues, the censorship
Centralization.
thing.
Yeah.
Yeah, censorship thing. So the main problem with IPFS is the same. Like there's no actually censorship or like anything that actually uh, incentivizes people to put bad data on IPFS. So like actually you can put up the deep web content on IPFS because like it's totally open and decentralized. So people have to come up with some system so that you can filter such things and bunch of other stuff that will be actually the value that will be added to the IPFS system.
Wait, so you're saying, did you say that there's no motivation to put illegal content or
So the point that I said that there's no incentivized system right now to de-incentivize the people to add bad content on it.
okay,
So like I can't stop anyone from adding bad data to it. So that's
okay,
a good thing, but like also it's not practical that much. So
okay.
you have to come up with some policies or like maybe social policies or like computational policies in order to solve this problem.
Okay. Yeah, yeah. Actually, that was my next question. So why don't we go there? So
Yeah,
yeah,
sure.
IPFS is it claims to be censor proof. So you if somebody wanted to remove content, they couldn't just attack a specific node that was
Yeah,
serving it because somehow it'll be copied to other nodes
yeah,
automatically. Or can you kind of elaborate on that?
yeah, sure. So like let's compare it to the today's world. So if I have to uh, uh, break the Google website. So what I have to do is like just attack the Google servers. So because I know the Google website is resides on specific servers, so I can just attack the Google website servers, and the Google website will go down. But in case of IPFS, if I just uh, host the same website on IPFS based system, I actually don't know which nodes have the Google uh, website. So like also this website will be all over the place. So like I have to actually attack the whole world in order to take that website down. So that's really potentially economically. So
So I hear what you're saying is that content is automatically spread across multiple servers.
yeah,
Okay. So okay, but that now I'm confused because okay, let's say that I had 2 terabytes of videos. Okay.
sure.
For example, this show I have a lot of videos, MP3 files, but let's say I had 2 terabytes of something and I put it on IPFS. Why is anybody else going to be willing to copy my content and host it on their computers?
Yeah, sure. Like this is a really big problem right now. So that's a basic. Uh, that was a basic problem when they actually started in 2015, 2015. So in order to solve this problem, they actually came up with Filecoin. So Filecoin is basically an incentivization system that comes over IPFS and like incentivizes people in order to like create a marketplace to store the files. So let's take an example. If you want some IPFS servers in order to store the files, and I have my some space in my laptop. So if I join the network with my laptop, you can actually give the files to anybody in the world that has some uh, storage left in their laptop. So I, what Filecoin is does creates a marketplace for the people, so that you can pay to anyone who can store the files for you.
Oh, okay. I would inject file coins or pay, and then
Yeah,
the machines would be selected randomly all over the world.
yeah. So it's basically like AWS, which is decentralized.
Okay, I see. And so it wouldn't be that people were choosing content and we knew where it was. It would
No,
just,
like the people wouldn't know what they are storing actually.
I see that.
So like, so I can hack into it and they see your videos. So the people who are storing can't actually do anything to your data.
Okay. Now, okay, so then that explains how the sensor resistance works then.
Yeah, sure.
People want to get paid they want to receive file coins, but they don't care what content that they're hosting.
Yeah,
They just care that they're going to get paid. Okay, and so that's
yeah.
all randomly distributed.
That actually unlocks a big potential economy. That's a shared economy for the data.
Okay. Now the fact that content is addressed with a hash, I can see one issue with that. I mean, I have no intention of putting illegal content on IPFS, but if somebody wanted to encrypt the content so that nobody could see
Okay.
it, now the hash is going to change, right?
Yes.
So I guess that would be okay. So then you would have a hash for the encrypted content and a hash for the decrypted content, and they would just be different. It would be treated like two separate files.
Yeah. Of
Okay,
course.
all
Like
right.
that. Yeah.
So people could choose to encrypt it if they wanted to, and they would just change the hash. Okay, that makes sense.
Yeah.
All right, now. Since you brought up Filecoin, so we can pay people to host content, the question that some people wonder is what guarantees do I have? I can pay people, but let's say I have something important like medical records. Do I really feel comfortable trusting other strangers with sensitive information that they're not going to erase it?
Let's say if I'm concerned that like my files will go, uh, I'll not be able to access my files if uh, a few nodes that I'm using to store my health records go now. So like what you can do is make that data more redundant. So like you can actually s- pay more for better redundancy. So if I want I'm not happy with one server storing my health records, I can ask 100 servers to store the same health record. That actually introduces the redundancy into the system. So you just have to pay a bit more to get more security out of it.
Right. Okay. Yeah. And hopefully, and then people can pay for as much redundancy as to make them be
Yeah,
at peace. Okay. Yeah, that makes sense. Yeah, I guess 100 for some applications, maybe 100 would be a good number, not too high. Okay.
yeah.
Now, so I've compared IPFS to BitTorrent, which I think people are probably the most familiar with. But there's also other systems people compare IPFS to, like Ethereum is developing Swarm, and then I believe SIA is another
Storage mechanism.
storage system. So can you kind of compare, say a little bit about all those different ones and how
Yeah.
they're okay?
So the basic difference between IPFS and systems like SIA is that IPFS knows it's not just a storage platform. So like I mentioned in the start of this talk, that IPFS is much broader. It actually aims to replace the HTTP sign that occurs on your uh, browser. SIA is just a storage platform, but like IPFS is also a communication platform. Like the lib-p2p, that is the peer-to-peer communication system that on which the IPFS is based on. Uh, Using that, uh, you actually can communicate with the user peer-to-peer, and like this actually differentiates these small scope projects like SIA with IPFS.
Okay. So don't think of IPFS as just a special hard drive. It's so
Yeah.
much more. I see. Okay. And so how is the current adoption of IPFS? Is the user base growing dramatically? I'm sure people always want it to grow faster, but
Yeah.
how's that? How's the adoption?
So basically, the adoption of IPFS is not that great right now. So it happens with every technology that has like really great potential. Like it happened with internet, it happened with the transportation system, it will happen with IPFS and distributed systems in general. So the problem is that the infrastructure that we have today is basically for the centralized system. So like the analogy that I gave earlier, uh, when the roads were not paved, the transportation, like your cars, were not able to like drive easily. They would break down like within like a few hundred miles. So basically, uh, the infrastructure is not right now, not great right now. So like in about like maybe 10 years or 20 years, we will we can actually expect like a big adoption of the decentralized system, not just the IPFS.
Right. Interesting. There's nothing wrong with the technology. It's
Yeah,
just that the user, what makes people take up certain technologies, that's a mystery. But there's no fault in IPFS. So yeah.
yeah.
Okay.
It
Yeah.
just takes time to like
Right.
get more familiar with the technology.
Right. This kind of reminds me, I remember in the 90s and then shortly after, I remember Linux. I thought Linux was so beautiful and perfect. And I thought Microsoft was always going to be the
Yeah,
world leader. But now today, right now they say Linux because of Android is the number one operating system. So if you just wait long enough, anything's possible.
yeah, of
Yeah.
course.
Yeah. Okay, good. So why don't we then, for the last part, why don't you kind of share about what your thoughts are for the future of IPFS and how IPFS is going to integrate with blockchain systems and kind of what do you think we can expect?
Okay. So right now, like we are doing some like I made a few apps. Like basically, we are right now hacking and like just making stuff work together. So like in Ethereum, you can like just like store the hashes in your smart contract so that like your smart contracts can actually point to your like cat GIF or anything. But like going forward, like this system will actually boil down to a better solution. So like maybe 10 or 20 years from now, we may not hear the word IPFS, but like the integral system that it is made up of, like lib-p2p and multi-hashing, that those are the things that actually will remain, because like IPFS is making systems that is interoperable so much so that like it can actually last for 100 or 200 years or like maybe more. So like a libptp is a like interoperable system that allows multiple protocols to exist uh, at the same time. So like in today, like in the centralized era, like if I have to change the protocol, I can't actually just swap in the new protocol. That will break the system, right? And like people's lives are dependent on these systems. So like we can't actually just swap and change the system. But like using libp2p, we actually can swap in the system so that we can test it, and like the development of these protocols will be so much easier.
So you're saying that it might be too painful to completely switch from the web to IPFS, but you're saying that the underlying technologies might make it easier, and then they might survive even if IPFS itself isn't the thing that we're using in the future. But okay. But so either way, we can expect a more decentralized future.
Yeah, of course. Like it for the fact, like Ethereum is actually adopting IPFS Lib2P system, and they are calling it Dev P2P.
Okay. So then other people are using. Interesting.
So basically, just I would like to one more point that there's one more system in IPFS called IPLD. So what is it does that like uh, it's actually any system that is hash based like that we actually talked about, any system that we can use that uses hashes, like we use GitHub, Bitcoin, and like Ethereum, like any cryptocurrency or any blockchain based system can be made on IPFS. So basically it's internet 2.0.
Okay. Oh, so we can host blockchain content on the state, the blocks on IPFS. Interesting.
Yeah, sure. So like you can actually actually point your GitHub commits and like the blockchain explorer and anything to your IPLD system, and everything will work like magic.
Okay, now you know what that just gave me the so okay, so what maybe in the future the way that one way we're gonna move to a more decentralized era would be like if websites started on the back end, they use IPFS more and more, and users don't even realize that they're using it.
That's right. Like right now, if I try to host my website, like it's really kind of slow when I load it. But like if a lot of people start adopting it, like it will be much more faster than the system right now.
Right. And how, by the way, like if somebody wanted to make a decentralized YouTube, right, they're obviously going to need a lot of storage requirement. So I assume that it's fairly cheap to pay for the hosting of all those videos to try to generate.
Yeah, sure. Because like right now the market for storage is not as open as it seems like, because like all the prices are uh, like set up by Amazon or any service that you use. But like when you open this market, like there's a ton of space left on your mobile or your laptop, and it's just lying around there. So if you can use that system, that actually unlocks a really big market that can like potentially drop the prices of the storage system to like maybe zero or like something like that.
Okay. All right. Yeah. Good. So you know what? You just gave me another idea. So the in order for a node to store the entire blockchain, it's becoming more and more difficult, right?
That's a big issue.
Hundreds of gigabytes. But if instead the blockchain was spread out over many computers, right, that would be a more efficient way to storage, and they would still have censorship resistance. They still have reliability, and it would just be stored more efficiently in a decentralized manner. So that's kind of an interesting idea also.
Yeah, sure.
Yeah. All right, great. So I think we've covered everything. I think the listeners got a pretty good introduction to IPFS. Did I forget to ask something or anything else that you want to say?
Yeah, I think like it was a good introduction to IPFS, and that I hope the listeners, will be more educated about IPFS before they watch this video.
Okay, great. And so your startup is called Towards Blockchain. And so it's Vaibhav Saini. So if you're interested in IPFS, you have a project for Vaibhav, then contact him at Towards Blockchain, and I'm sure he'll help you out. So great. Yes, thank you. Thank you, Vaibhav, for spending time with us and enlightening us on IPFS.
I'm glad to.
All right. So best of luck with your future plans, future projects.
Thank you.
All right. Bye-bye.